Hello everyone. In this second lesson of Unit 9, we will treat those rules that help us with solving topologies at the pinch. These two feasibility criteria must be met to solve pinch topologies and are the stream population criterion and the adequacy of thermal inertia 1. We are saying that meeting these two criteria is compulsory if you want a minimum network design. They can be not met, but you don't reach a minimum network. Gonna here do two. The stream population criterion says that the number of streams leaving this side, the one we are designing, of the pinch must be equal or greater than the number of streams arriving to it. And the adequacy of thermal inertia in pin matches said that the thermal inertia, the MCP, of each stream arriving to this side of the pinch must be equal to or smaller than that of the stream that matches. If both criteria are met, matches can be chosen as we want on startup, operating, safety, engineering judgment, and the network will be a minimum one. Gonna explain it in more detail. The stream population criterion says that the problem are those streams that arrive to the pinch, not those that leave the pinch. This is because at this side of the pinch we cannot use utility, the other utility that take this stream to the pinch. In this case, heating. Then, for the matches to be made, you must have one stream leaving the pinch for every stream arriving to the pinch. In this example, we have met two of the stream arriving, but we have no stream at the pinch temperature to meet the needs of this third stream arriving to the pinch. And the other example is the same thing. We have just one stream leaving the pinch and two streams arriving to the pinch. We have one stream left alone without the minimum temperature approach stream to meet its needs. If this is the case, some stream must be split to meet the criterion. And this is because we have not enough temperature to carry every cold stream to the pinch in this example. Then the thermal inertia of the split stream is divided this way. And we can split it with a ratio at our will. That will be such that meet the adequacy of thermal inertia criterion. Those splitting ratios will be one of the parameters to optimize in the evolution stage, because there is normally a range of validity for these splitting ratios. The other criterion, the adequacy of thermal inertia, is a question of slopes. Remember that the thermal inertia is the reverse of the slope in the temperature versus enthalpy diagram. Then, for two streams arriving at the pinch in the cold side, the slope of the hot stream must be smaller than the slope of the cold stream. On the contrary, as we go out of the pinch, the temperature difference will be reduced violating the minimum temperature approach. And a similar thing above the bench. Two streams arriving to the bench, the hot stream must have a greater slope than the cold stream. On the contrary, the difference in temperature will be reduced as we go out of the bench. Then, seeing the values of thermal inertia, we can see what matches are allowed and what are not. In some cases, stream must be split to meet the adequacy of thermal inertia criteria, not the population criteria. In this example, this 10 MCP stream can be matched with one of those 4 and 5 MCP streams, but the 3 MCP stream cannot be matched with any of them. Then we are obliged to split this stream in order to match the two streams arriving to the bench. Be clear that this heat exchanger is not a bench one, because one of the streams doesn't touch the bench. Remember also after splitting stream to recheck the population criterion at the bench.